benzene, benzene, they will undergo a few reactions, benzene and methylbenzene, they will actually undergo few reactions, which is going to be, the first one is going to be halogenation. Halogenation is going to be considered to be electrophilic, electrophilic substitution reaction. So I'll just write down over here, substitution reaction. And if I want to represent, if I want to represent the reaction, let's say, for example, if I have a benzene, and I'm going to actually react with Br2, I am going to get, the hydrogen is going to be substituted by the Br, and I am going to get HBr. This is the full equation. But you need to know how to write, the mechanism of the reaction. So if I write down the mechanism of the reaction, the first thing is going to be by using, the catalyst or the halogen carrier. And I told you during the lecture yesterday, I think I got cut off again. I think I got cut off again. So again, I'll repeat again. This is going to be the equation, for the electrophilic substitution. It is very important, that you know that this reaction is going to use the catalyst, which is going to be anhydrous, anhydrous AlBr3. So this is the change that I introduced to you yesterday. No need to use the FeBr3. So anhydrous AlBr3, we are going to use this. So the mechanism of the reaction is going to be, you are going to have AlBr3, you are going to approach the Br and Br, so what's going to happen, the AlBr3 is going to polarize the Br2, so you will have delta negative and delta positive. Next, what's going to happen, the delta negative will go over here, and they will give you, AlBr4, then put a bracket, minus plus Br plus, which is going to be our electrophile. Next, what's going to happen is going to be, you put the benzene, you put the benzene, and we are going to actually bring the Br plus over here, which is going to be our electrophile. And this electrophile will attack, the benzene ring. But when we show, make sure you show properly. It's going to be something like this, where two electrons, or one pair of electrons, they will actually go out and form a new bond, with the Br, and then the H, the previous bond, is still remains there, but this one is going to become incomplete, where we have 4 electrons being shared, or the positive charge is going to be shared among 5 carbon atoms. So that is going to be what is happening. And this reaction is not going to be like, for example, the benzene ring must be stabilized. Sorry guys, I'm getting frequently disconnected. Hold on. Try to place the modem in different place. Now, so if you look at it, so the electrons, they will actually, they need the electron back, so the pair of electron will start to move in. So you are going to get, the bromobenzene, you will get the bromobenzene, and then the H plus. And do remember the H plus, they can join, with the AlBr4, where they can give you AlBr3 again, and also the HBr. This is the mechanism of the reaction, when it comes to benzene, when it comes to benzene. Now, this reaction, if I want to represent, if I want to represent for methylbenzene, So if I want to represent for methylbenzene, it's going to be like this, okay? It's going to be, if I have methylbenzene, okay, do remember methylbenzene, okay, they still going to react with the Br2, okay, but they still require AlBr3, okay, the catalyst is still being required, okay, but, okay, the methyl group is going to be 2,4,6 directing. Okay, so you are going to get, okay, maybe first, okay, this one, of course, you're going to get HBr also here, okay, but you are going to get the CH3 here, okay, I'll just write the equation only, okay, you can get, okay, the Br coming over here, okay, 2,4,6 directing, right? So it can come over here, okay, and it can be also, okay, 2,4, okay, so 2,4, it can be also like this, okay, and then, okay, it can be also going to be, the Br can come over here, okay. So if you look at the lecture notes, yeah, you can see that, okay, the reaction, okay, if you look at the reaction for the methylbenzene, okay, they say that, okay, first you are going to get, okay, if it is not in excess, you are going to have mono-substituted mixture. But after that, they are going to have more mixture if it is going to be in excess. So if I put it down properly, yeah, so if I remove the one that I added just now, okay, hold on. So maybe first, okay, you are going to get the Br here, okay, plus, okay, you are going to get the methylbenzene, okay, with the Br here, okay, 2,4, okay, sorry, one is going to be the Br here, another one is going to be the Br here, and then the Br here, okay. And if it is going to be, of course, this is going to be HBr, okay. And of course, okay, this is not balanced, okay. We are not looking into the balancing part, but if you want to balance, yeah, definitely you can do it, okay. But here, okay, if it is going to be in excess, if it is in excess Br2, okay, what you are going to get? You are going to get, okay, I think I made a mistake. This is the one in excess. Okay, this is the one in excess. So if it is in excess, you are going to have another one more. Okay, CH3, Br here, Br over here, and Br over here. Yeah, this is going to be if you have excess. If it is Br2 alone, yeah, just like normal, okay, you are going to get mono substituted. So it means CH3, Br here, and then you will have CH3, Br here, okay. Of course, I'm not going to put this one, CH3, Br here, because it's the same as this one, yeah. So I'm going to erase this, okay, plus HBr. Okay, I hope this one is clear. Yeah, Frederick, is it okay? Can you follow?
Yes, sir.
Okay, so I put this, okay, this one separate. Yeah. So later, yeah, so the next part is going to be the free radical substitution. Now, this free radical substitution, yeah, do remember, it's not applicable, okay, not applicable for benzene. Okay, it's not applicable for benzene. It's only applicable to alkyl benzene. So which is going to be, it's applicable for methylbenzene, for example. So let's say if I write down a methylbenzene over here. Okay, so CH3 plus, let's say, for example, Cl2. Okay, under the presence of UV light, do remember it must be boiling. Okay, must be boiling. And what happens, okay, this is very, very important. Okay, the Cl will not come to the, okay, to directly substituted to the ring over there. Yeah, that is not going to happen because, okay, there is no halogen carriers. Yeah, there is no halogen carriers over here. So that is not going to happen. So what is going to happen is going to be, you are going to have a benzene, okay, and then the CH2, one of the H is going to be substituted. You get CH2 and then Cl plus HCl. And this is going to continue, okay, this is going to continue until all the hydrogen over there is going to be fully substituted. So you will have CHCl2, and then when they continue, you will have, okay, CCl3. Yeah, so that is going to happen, okay, when it comes to this free radical substitution. Okay, so that's the mechanism of the reaction. Do remember, yeah, when this thing is happening, yeah, so there is no going to be direct substitution to the ring because there is no there is no halogen carrier over there. So the next part is going to be nitration. Yeah, nitration is going to be, you need to have a nitrating mixture. So the nitrating mixture is going to be made from concentrated H2SO4 and concentrated nitric acid. So if we want to write down the equation, but before that, okay, we told you to memorize 55 degrees Celsius in your textbook. Okay, it's written 55 degrees Celsius, but in your syllabus is 20 to 60 degrees Celsius, if I'm not mistaken, or 25 to 60 degrees Celsius. Okay, so you, but for me, I'll just, we stick to 55. Yeah. Now, this reaction, okay, if I want to put it over there, okay, it's supposed to be nitration is going to happen, okay, with benzene. Yeah, with benzene. So this is going to be reacting, let's say, for example, if I want to write equation only, so HNO3, I will write down, okay, because one of the H is going to be replaced, okay, with NO2, yeah. So there is one H, okay, went out, okay, from here, replaced, and then NO2, okay, so there is O and H. So if you join all of them together, you are going to get H2O. This is if you write the equation. Okay, but if you want to write down the mechanism of the reaction, okay, I will always suggest that you write down the equation first. H2SO4, okay, plus HNO3. If you want to memorize, you put the 2 over there. They are going to give you NO2 plus, which is the electrophile, plus 2HSO4 minus, plus H3O. Yeah, the important part is to get the electrophile. And this electrophile later is going to react, okay, to this benzene molecule, okay. So they say the electrophile will attack, okay, the benzene, yeah, the electron benzene ring, the high density of electron, okay. But don't actually make the mistake because the curly arrow must be pointing, yeah, the movement of the electron. So it's supposed to be the other way around. And this is going to give you, yeah, this is going to give you a benzene molecule. 2 electrons is being used to form a new bond, okay. So it means that there are 4 electrons where the charges are going to be the positive charges shared among 5 carbon atoms. And this is going to be not stable. So what happens, okay, the 2 electrons, okay, they need to come back, okay. So they take from the hydrogen. So heterolytic fission will happen, yeah. So the hydrogen, okay, will be left as H plus, and this is going to give you the nitrobenzene. So you'll have NO2 over there. As usual, this H plus, okay, you can actually join with this and they can actually give you H2SO4. But what you will notice that is going to be in the main equation, you wrote it as H2O, yeah. You are not getting that H2O over here, yeah. So that one, no need to worry, yeah, no need to worry, okay. This one just when you show the steps and the mechanism, it's enough. If you show like this alone, it's enough. Even you mention it gives you H plus, is good enough already. But okay, you need to remember this reaction does not stop over there only. There can be there can be further nitration. Now, further nitration is very important because okay, now we are going to actually use the NO2. NO2 is going to be okay, it's going to be electron withdrawing group. So electron withdrawing group is going to be different than electron donating group. They are going to activate position 1, 3, 5. Yeah, but they already took the position 1, okay, NO2 over here. They are going to activate position 3 and 5. So if you have further nitration, so if I put it as let's say, for example, with this color, further nitration can happen, okay, where they are going to have, okay, the NO2, the nitrobenzene. The NO2 can come at position number 3. This is position 1, position 2, position number 3. NO2 can come over here, okay. And there is going to be another further nitration that will happen where they can continue to react, okay, to give you the 1, 2, 1, 3, 5. Yeah, so I'll just put NO2, okay, position 1, 2, 3. So this is NO2 over here. 4, 5. Okay, so this is NO2. So this is what they meant by further nitration. Okay, so further nitration can happen. So you can have this. Okay, please take note. It must be, you need to follow the electron withdrawing condition. Yeah, so they will have the further nitration that way. So that is still going to be, if you look at it, yeah, I told you electrophilic substitution number 1. This is free radical substitution. Nitration is still, it is going to be again electrophilic substitution also. Yeah, electrophilic substitution. And if you move on further, okay, that the next one is going to be Friedel-Crafts reaction. Okay, this is going to be electrophilic substitution also. Yeah, electrophilic substitution, and this is going to be applying to benzene. Yeah, so electrophilic substitution, and we have 2 types, which is going to be alkylation, and we have acylation. Okay, both of them are considered to be Friedel-Crafts reaction. Okay, so let's say actually I'm writing down example for alkylation. Yeah, so if I have a benzene, yeah, and I want to actually put alkyl group, okay, let's say CH3, yeah, I want to make methyl benzene, yeah, so make sure CH3 is bonded to a halogen. Yeah, very important. Yeah, so Cl. And then you need to make sure, okay, that this is going to be heated. Yeah, heat. Okay, and then you need to have the catalyst, which is going to be AlCl3. So you see now, you no need to remember FeCl3 and so on. Everything is like AlCl3 or AlBr3. Yeah, so if it is like this, okay, AlCl3, and they are going to give you, okay, the CH3 will go there. And you will have the H from the benzene and then the Cl from halogen alkane. They are going to join to give you HCl. Yeah, the same thing, okay, will be applied over here for acylation. Okay, acylation. Let's say I'm going to actually this is acyl group. Yeah, C double bond O, and then you have the R group. Okay, let's say the R group. I want to use CH3. Okay, make sure the same thing, you need to use halogen. Yeah, but now I'm going to use Br, for example, so that I can show you different example. So if you use the Br over there, so what you need to use, you use AlBr3 heat. Okay, and you will get, okay, you will get the benzene, and you are going to get carbon. Okay, so basically this part, okay, this part of, okay, let me change the color. Yeah, this part, okay, will be taken. Yeah, so this one, C double bond O, and then CH3. Okay, the H came out with the Br, so we'll have HBr. So this is going to be the products, okay? And of course, we need to know the mechanism of the reaction, yeah? I will show you the mechanism for the alkylation, yeah? For acylation, still the same, yeah? So I think last time I showed you the mechanism for acylation. Okay, now I will show you the mechanism for alkylation. It's still the same, yeah? So first, okay, what happened? Okay, you will have CH3, okay, Cl coming closer to AlCl3. Okay, and then what happened? AlCl3, no need to polarize, okay, this molecule because it's already polarized because Cl is more electronegative. Okay, the electron will go there. No need to tell that AlCl3 need to polarize. No need. Okay, so the delta negative will come over here. Okay, so they will form a coordinate dative bond to Al. Yeah, because Al has empty d orbitals. Yeah, so they are going to give you AlCl4 minus and Cl plus. Okay, which is our electrophile. So this electrophile, what we want to do, they are going to actually react. Okay, they are going to react with the benzene. Okay, then they will react with the benzene. Okay, so I will just write for you. Okay, they will form, okay, a chlorobenzene over there. Hey, sorry, made a mistake. Not Cl plus. Okay, so this one is going to be plus with CH3 plus. Okay, CH3 plus. So they are going to react with the CH3 plus. Okay, so let's say I put the CH3 plus here. Okay, so you are going to get H and then CH3. And this one is not complete. Okay, so next is going to be the electrons from here will come over here, the two electrons. And you are going to get, okay, the methylbenzene. Okay, and then H plus. You can leave it over there, or if you want to show, they will react with this also. Okay, okay, when they react, okay, they are going to give you AlCl3 and HCl. Okay, so this is the mechanism. Yeah, this is the mechanism for this reaction. So again, you see, it's a electrophilic substitution. Okay, that doesn't mean that you no need to know the mechanism for free radical substitution. Yeah, this is very important. I think for AS, you need to know. So you need to also, you are expected to know all the mechanism: initiation, propagation, and termination. Yeah, if they ask. Okay, so the next is going to be oxidation. Yeah, for the oxidation, yeah, we cannot oxidize benzene. Yeah, so it means this is a special. Yeah, so it's oxidation. Yeah, so it's not free radical substitution. It's not electrophilic substitution. It's a separate one. Yeah, separate mechanism. So the oxidation. Okay, in order to oxidize. Okay, you need to use KMnO4. The difference is, okay, you must use alkaline KMnO4 because normally we use acidified KMnO4. Okay, in this case, we have to use alkaline KMnO4. Okay, and then, yeah, and then only after you react with alkaline KMnO4, they say it's heat, yeah, or you can actually heat under reflux, up to you. Okay, and then you add acid. Okay, that acid must be dilute. Okay, so dilute acid. So in my notes, I put H2SO4. So it means alkaline first, then you add dilute acid. So slightly different. Okay, and what will happen? Yeah, benzene cannot be oxidized. So I'll just methyl, yeah, methylbenzene. Okay, when you oxidize, okay, you can see it's going to be 3O. Okay, I think the equation you can figure out yourself, yeah, how to write the equation. So basically, you are going to get a benzoic acid, COOH, yeah, COOH plus water. Okay, so this one, if you do, basically it's going to be balanced. Yeah, so sometimes, okay, students will be wondering what will happen, okay, if I have, okay, C2H5. Yeah, so you are not expected to know how to write the equation, okay, but you are expected to know the product. Okay, the product must be the same, which is going to be benzoic acid as well. To remember this. Yeah, so some students will be asking, sir, there is going to be 2 carbon here, why suddenly there's only 1 carbon? Where the another carbon go? Yeah, the another carbon go as carbon dioxide. Yeah, so please remember this. So you are going to get benzoic acid. Benzoic acid doesn't matter how many carbon is attached to the benzene over there. You are going to get benzoic acid. Okay, benzoic acid. Okay, this one is under oxidation. Now, this is the last part that I didn't teach you. Yeah, so this one is hydrogenation, which is going to be the reason why I didn't teach you, or it's not found in my old notes. Okay, because this is a new addition in the syllabus. Yeah, so hydrogenation, yeah, is going to be a electrophilic addition reaction. Yeah, electrophilic addition, because okay, normally I told you electrophilic addition doesn't happen for benzene. Okay, why? Because what we call as aromatic stabilization. Okay, the aromatic stabilization is going to be because of the delocalized electron, the benzene ring. It will stabilize the benzene structure. So they do not undergo addition reaction. They will actually have tendency to go electrophilic substitution. But electrophilic addition can still happen under harsh condition. Yeah, so the harsher condition means it must be high temperature, high pressure. So they do happen for benzene itself. Okay, the reaction is going to be hydrogenation. So if you have the benzene and I'm going to actually react with the hydrogen, okay, the catalyst is going to be platinum or nickel, and they say in your syllabus, they say high temperature. Yeah, and I would like to add to it, it must be also high pressure. Yeah, so in your syllabus they say high temperature only. Yeah, I'm adding high pressure also, and they are going to give you, yeah, cyclohexane. So cyclohexane means they don't have the circle over there. Okay, what is cyclohexane? This is C6H6. Cyclohexane is going to be similar to CnH2n, yeah, which is going to be cyclic structure. They will follow something similar to alkene. I hope you remember. Yeah, a cyclic structure. They will use the general formula of alkene. So this is going to be, but they don't have double bond. Yeah, so this is going to be CnH2n. So they will actually follow C6H12. Each carbon has 2 electron. Each carbon has 2 hydrogen. Yeah, so that is going to be cyclohexane, and you need to have 3 moles of this. Yeah, and this thing, okay, if you compare with the alkene, okay, if you have alkene, okay, they do have, okay, electrophilic addition, but they will use nickel or platinum at 140 degrees. So if you compare with this, do remember benzene is going to be more difficult to react. Yeah, it's going to be aromatic stabilization. If they say they didn't give you exact temperature, but I personally think that high temperature should be higher than 140. Yeah, so probably we are looking into maybe 200 degrees Celsius or something like that, but definitely not 140. Yeah, definitely not 140. It should be higher than that. Okay, so this is these are all the, okay, all the reactions, yeah, that you are expected to know from this chapter. Yeah, so any questions?